Redox reactions, why do we call these redox reaction? Because this is reduction and oxidation taking place simultaneously, means at the same time. That's why the name. Okay, redox reaction. Redox from reduction, okay, ox from oxidation. And there are very specific, very easy rules. Don't go through NCRT for this chapter. Avoid NCRT. Okay, because there is a story about whatever I am telling you in just 2 slides. There is a story in 4 5 pages, and that too is very much confusing. So oxidation, we will say that oxidation is taking place when any of these is happening. What I am going to mention, whether there is addition of oxygen taking place, and this is something you know from your previous classes as well, that magnesium when reacts with oxygen, it gives you magnesium oxide. So oxygen is getting added on magnesium. If you see from magnesium to magnesium oxide, oxygen getting added. So in this case, you will say magnesium oxidized to MgO. Addition of oxygen is oxidation. And this definition you know from your previous grades. Okay. The other one is removal of hydrogen. Then also we will say it is oxidation, although there is no involvement of oxygen here. But if hydrogen is removed, we say it is oxidation. For example, you have hydrogen sulfide and it reacts with oxygen, you get 2s plus 2h. Now, if you see from here to here, hydrogen is removed. Here, sulfur was attached with hydrogen, but here there is no hydrogen. So this is oxidation. Okay, sorry, oxidation, not oxidized to sulfur. Oxidation can be explained on the basis of multiple definitions, and all 6 definitions I will be talking about here. Okay. So the first one is addition of oxygen is there. You will say oxidation is taking place. Removal of hydrogen, again, you will say oxidation is taking place. Now, after that, scientists modified this definition. Oxygen is electronegative. So scientists said that addition of not only oxygen, any electronegative element. Just a second. Yes, Devyansh. Yeah, good evening. It looks a problem with your device, I think, because everyone is able to listen to me. It's not happening with anyone else. Just change something, whether you are listening to, whether you are connected to any headphone or earphone, or you are using the voice laptop speaker. Might we try another network instead of Wi-Fi, try the mobile network? Because it is strange that only you are facing that problem, right? No one other. So it can't be figured out where the problem is. Okay. Yes, fine. Okay. So the definition was modified, that addition of any electronegative element, not only oxygen. So for that, for example, Mg got reacted with Cl2, MgCl2. So now magnesium oxidized to MgCl2 because electronegative element got attached to magnesium. Comparatively electronegative element got attached. Similarly, the definition for hydrogen was also modified. Removal of hydrogen, and hydrogen is electropositive. So it was modified that removal of any electropositive element will be treated as oxidation. Okay. Whether it is hydrogen or any other electropositive. So these two are similar ones. These two are similar ones. Addition of oxygen or any electronegative element, or removal of hydrogen or any electropositive element. In both cases, we will say it is oxidation. For this one, the example is We have potassium ferrocyanate, and this is coordination compound. We will talk about coordination compound in 12th. And when it reacts with hydrogen peroxide, one potassium is removed. So we have probably two here. Yes. Now, so this compound had four potassiums, and potassium is electropositive element. One was removed, only three now, from K4 to K3. It means this substance is oxidized to potassium ferrocyanate, oxidized to mm, okay, Devyansh, good, good. So here we will be talking about the charges. So here it is plus 4. So here will be 4 minus, because here we have plus 4. Here it will be 3 minus. Depending on that, we will say here it is Fe2, here it is Fe3. So, but more about it in 12th grade, not here. So it is potassium ferrocyanate. Oxidation state of iron is different. So write down the examples. You will be asked about the examples if these type of questions appear. Next one is loss of electron. So till here we were talking about the elements. So first four, which are actually two, because if you just remember this one, this contains oxygen also, because oxygen is electronegative element. If you remember this one, it is sufficient. If you remember this one, removal of any electropositive element, this one is sufficient, because hydrogen is also electropositive element. The next one is loss of electron is also treated as oxidation. Example is, for example, sodium gets converted to sodium ion and one electron is released. So it lost one electron, it means it is oxidized. Okay. So the real example, zinc plus copper sulfate solution. So copper sulfate can be written as Cu2 plus. It actually gives you zinc sulfate, which will be written as Zn2 plus and copper. So zinc loses two electrons, this gains two. So because zinc loses two electrons, here it is oxidation. Okay. So loss of electron, I normally combine and make one word so that you can remember. I call it loss of electron is oxidation. So remember the word oxidation. This is not any word, right, in dictionary. Just for your reference, oxidation, L stands for loss, O for oxidation. Loss of electron is oxidation. Because in case of elements, we use the word removal, not loss. Loss is only used in case of electrons. Next one is increase in oxidation number of the element. Now, if you noticed, when I said Na gets converted to Na plus plus E minus, this charge is most of the times is oxidation state. The valency is similar to oxidation state. I will be talking about oxidation state in detail about the rules of oxidation state later on. So here oxidation state was zero because this was neutral. Here oxidation state plus one. So it means oxidation state increased when it lost one electron. So loss of electron and similar one, I'm not saying same thing because these are two different things. Increase in oxidation number of the element is also oxidation. So here it is oxidation, we can interpret it as increase in oxidation state also from 0 to +1. Now, how do you find oxidation number or oxidation state? Oxidation state and oxidation number for you same thing, right? Oxidation state just means that in which oxidation number it is. Okay, what is the oxidation number it carries? State is just in which condition it is. Okay, oxidation number is that number which it carries. So both will be used interchangeably. So these are same thing for you. Oxidation state and oxidation number. Now, how do you define the reduction? Reduction will be just opposite of these. In case of addition, you need to have removal. In case of removal, you have to have addition. Here you have to have gain, and here decrease. So just opposite of these will make it reduction. Removal of oxygen or any electronegative element, reduction. Addition of hydrogen or any electropositive element, reduction. Instead of loss, gain of electron is reduction. Instead of increase, decrease in oxidation number is reduction.
Sir,
Yes.
sir, you will last point समझा दीजिए oxidation.
That you won't understand because I will explain that in detail. As I said, I will explain oxidation number in detail. Then you will be able to understand that.
Okay, sir.
So I would suggest that you remember only for oxidation. Don't remember for reduction. Otherwise, students get confused. Just remember these points for oxidation. Opposite of this will be reduction. If you have not written, write these 6 points of oxidation definitions in your notebook and make sure that after the class also you memorize these points. These will help you to grasp this chapter very easily. Now oxidation number. Oxidation number as such does not have any specific clear definition. Okay, there is no specific clear definition. It is just understanding. Okay, so and why we need to talk about oxidation number? In order to keep track of electron shifts in chemical reactions involving formation of covalent compounds, a more practical method of using oxidation number has been developed. When we say more practical method, it means moving from valencies. Earlier we used to talk about valency. Now we are talking about oxidation number. And why we are talking about oxidation number? Because in case of valency, normally we say, if we talk about oxygen, we say oxygen has 6 electrons. It can gain 2 electrons and attain noble gas configuration. So -2 charge, or you can say -2 valency. But oxygen actually combines with many elements and forms the compounds which do not show valency as 2, -2. Okay. So for example, if you have H2O2, if you have OF2, oxygen actually is showing positive valency and not negative, because fluorine is negative. Oxygen is comparatively electropositive. Do you know that? You understand fluorine is more electronegative. So it means fluorine, if more electronegative, oxygen cannot have negative charge. It must have positive charge. So this cannot be explained on the basis of valency. For that, we have oxidation number concept, which is similar to valency, but it actually talks about how many electrons are getting transferred. Simple. Okay. So it's a method to keep track of electron shifts.
Yes, sir.
That's and it is more evolved way to understand the compounds as compared to valencies. And there are rules. And these rules you have to understand very specifically. Why? Because these rules will help you to answer the questions where you will be asked to calculate the oxidation number. And oxidation number anyway will be required when we will be talking about balancing of reactions. So there are two very important methods we will be talking about to balance the reactions. For that, you have to have good knowledge of how to calculate the oxidation numbers.
Sir, can you please move to the previous slide?
Yes. Yes, sir.
This one,
Yes, sir.
Yes, sir.
Done?
Yes, sir.
Yes.
So the first rule is very simple. If you have elements in their free standard form, okay, although standard is not written here, I am saying standard form. Why? Because in standard form, hydrogen exists as H2, not H or H3, H2. Oxygen exists as both O2 and O3. So in their standard free uncombined form, oxidation state will always be zero. So in a reaction, if I have written Mg plus O2 gives you MgO, tell me which one will have zero oxidation state.
Sir, can you
The
again
O2.
the oxidation number?
I'm saying the first rule, this is just the first rule. The first rule is if elements are in any reaction, elements are in their free uncombined state. It means they're in standard form. Then their oxidation state will be zero. Now tell me,
Sir,
in this reaction,
magnesium.
in this reaction, which will have zero oxidation
Sir,
state?
O2.
Magnesium.
O2, sir.
Sir, O2.
Arjun, correct?
Sir, magnesium, sir.
Both magnesium and oxygen will have zero oxidation state because both are in their standard form. Okay.
Yes, sir.
Okay.
Magnesium is not in ionic form. Oxygen is not in ionic form. Magnesium, if you say how you will find pure magnesium, it will be just Mg. How you form the pure oxygen, it will be just O2. Okay. So wherever you have, and I had already written it in the examples. That's why I asked. You had these two in the examples. You could have seen it from here. All the elements in their standard form. The standard form means how they exist at room temperature. Okay, so S sulfur exists as S8 molecule. 8 atoms of sulfur are combined together. More about it we will be talking about in P block elements
Sir,
chapter. Yes,
sir, do we have to apply this rule at the result side or both sides?
both side you need to apply in the
Okay,
reaction. Okay. So it exists as S8. That's why its oxidation state will be 0. Sulfur's oxidation state here will be 0. Phosphorus oxidation state here will be 0. Aluminum oxidation state will be 0. So if it is just in elemental form, in its standard form, oxidation state will be 0. Next one. For ions, composed of only one atom. One atom, these are called monoatomic ions. So for monoatomic ions, whatever is the charge, that is the oxidation state. Oxidation number is equal to charge on the ion. Second rule is again very simple. Now you don't have elements in their standard form. Rather, elements are in ionic form. So if I say Cl minus, its oxidation state is -1. If I have O2 minus, its oxidation state is -1. If I have O2 minus, its oxidation state is -2. If I have Al3 plus, its oxidation state is +3. So up to here, basically, we are talking about the valency. This point is actually equal to valency because if you compare it with ions as valency, it is same thing. The charge is equal to the valency. So second point is again very easy. I'm just asking an example. So suppose I say that zinc reacts with CuSO4 and it gives you zinc sulfate plus copper. Tell me the oxidation state of zinc, copper, zinc, copper. 1, 2, 3, 4. Write in the chat box. All answers in one row. Don't tell me just one or just two. 1, 2, 3, 4, all in one row. Okay, Yash Bedi got the answer. Good. Just write, don't write 1, 2, 3, 4. Just give me in that sequence, okay? Oxidation states in the sequence, not on mic, only in chat. Pratham, read the rule again. Vedant, read the rule again. Ariman, read the rule again. I have specifically written this reaction in this form.
Sir,
Yes,
sir, can you please please explain the second rule again?
I will. After this one, I'm going to explain. That's why I have given this example, right?
Yes, sir.
Okay, Pratham, no, Samat, no. Now, if I modify this example and I write it like zinc plus CuSO4 is actually copper has +2 charge and SO4 -2. So now I write it in this form. Now tell me the answer. What are the oxidation states in sequence? 1, 2, 3, 4. Okay, Ishwar, now you got it. Okay, Pratham, now you got it. Yes, anyway, you had written it earlier correctly. Kartike, yes. Arjun, yes. So now you see that zinc is in its standard form. It is not an ion. Oxidation state here will be 0. This is copper ion +2 charge, oxidation state +2. Similarly, here +2, here 0. Copper at the
Sir,
product
actually,
side, yes.
sir, actually, sulfate was given in CuSO4 and ZnSO4. That's why I got confused.
Right. So that's the way how you will find the answer, because
Sir,
CuSO4 is actually Cu2 plus SO4 2 minus. So if I ask
okay.
the oxidation state of copper, you will consider it as Cu2 plus. It is ionic compound. Yes,
Sir, did you ask the oxidation state of copper sulfate as a whole or only copper in this case?
only copper.
And okay, sir, if it was asked for copper sulfate as a whole, then it would have
There
been
is
zero.
there is no such concept that you can calculate the oxidation state of the whole compound. Okay,
Okay,
the oxidation, there will be some of oxidation states of the elements, but we will be talking about in terms of oxidation states of elements within a compound.
yes, okay,
So in normal cases, the oxidation state of elements will be equal to their valencies in normal cases. Okay? But why we have a concept of oxidation state? Because in many cases, they do not have oxidation, they do not have charge equal to the valency. That's why the concept of oxidation state. That charge is exactly how many electrons are being transferred in reality. Okay. Now the third rule, and this rule is actually the one where many students make mistake. They actually don't uh, recall this rule and just apply the other rule. All alkali metals have oxidation number 1. It means whatever the compound is, oxidation state will always be +1. What I said, oxidation state of all alkali metals, lithium, sodium, potassium, rubidium, cesium, francium, will be +1 in their compounds. Okay. Clear? So now I ask a question. The question is, Na solid gets reacted with half Cl2 and gives us NaCl. Okay. What is the oxidation state of sodium, chlorine, sodium, chlorine? At least 3. Don't talk about third because this is something I have not told you. So tell me the answer in chat window. What do you think the oxidation states will be? 1, 2, 3. Arna, excellent answer. Good. Amir, good. Yash Bedi, good. Vedant, think again. Kartike, good. Ariman, good. Pratham, think again. Kavish, think again. Atman, think again. Arjun, no. Think again. Laksh, no. Subway, okay. Third one, you said yes, correct. Ishwar, no. Apply all the rules, okay? We have talked about 3 rules till now. Third rule, obviously, in progress. 2 earlier ones also. This is the standard form of sodium. This is the standard form of sodium. And that's why I had encircled at the top in their compounds. So read that statement again. In their compounds, I have encircled. Not a standalone. In their compound, they will always have +1 oxidation state. A standard form oxidation state will be 0. Chlorine also exists as Cl2. So here also oxidation state will be 0. But here it is compound. It will be +1. That is
Sir?
the, yes.
Sir, in Na, sir, but it is alkali metal, so sir, why can't we write it as +1?
Okay, because it is not attached with anyone. It is transfer of electron. We in oxidation state, we are talking about transfer of electron. But if it is like NaS, has it transferred electron to anyone? No, it is just sodium. You don't have these. You have just sodium. And is there any electron transfer?
No, sir.
Sodium, right? Similarly, if you just have chlorine, do you have any electron transfer? No. But when they combine and they form NaCl, in NaCl there is electron transfer from sodium to chlorine.
Yes, sir.
So that's why, because it lost 1 electron, +1 oxidation state, chlorine gain 1 electron, -1 oxidation state.
Yes, sir. Got it.
Sir, can you explain the Cl ones again?
Cl1, I will come again, okay, later on. So just here for
Yes.
reference, I explained. So later on, I will talk about chlorine. All alkaline earth metals have oxidation number 2. Means group 1 elements in the periodic table always +1, irrespective of what compound they are in. I'm using compound, okay? In standard form, it will be 0, but in their compound, always +1. Similarly, alkaline earth metals, group 2 elements, always +2 in their compounds. In their standard combined form, it will be 0, but compounds +2, always. Does not depend what compound we are talking about. Similarly, aluminium also here. So here we talked about lithium, sodium, potassium, rubidium, cesium, potassium. +2 will be this one, +2 here. Beryllium also. Beryllium, magnesium, calcium, strontium, barium, radium. These have +2. Aluminium will always have +3. Only aluminium, we are not talking about all, only aluminium in 13 element always has +3. Means it transfers 3 electrons from it. That's it. The reason is very simple. That's it. So aluminum is regarded to have an oxidation number always 3 in all its compounds. So +1, +2, +3, you should remember that if these 3 appear in any compound, you will always consider oxidation state as +1, +2, or +3. No exception here. No exceptions. This will always apply. Now the fourth rule. The oxidation number of oxygen in most compounds is -2. And this rule is actually the lengthiest one out of all rules. Because oxygen actually shows 6 oxidation states. And you need to know all. Two, you already know. The first one, for example, in normal state, O2 or O3, it will be 0. You know that. In most of the normal compounds, it will be -2. So if it is normal compound, say Al2O3 or CO2, NO2, CO, it will be -2, normal oxide. But in few oxides, that is peroxides, superoxides, the oxidation state of oxygen will be different. And also, when oxygen is bonded to chlorine, peroxide, you know, H2O2, superoxide, KO2. Superoxide means oxygen is more than required. Normally, in normal oxide, potassium has +1 and oxygen has -2, so it should be K2O cross. So that is normal oxide. But KO2 actually has more number of oxygens as compared to normal oxide. So greater number of oxygens as compared to normal, it is called superoxide. And this is peroxide. In peroxide, the internal bond of oxygen is like this. So this is called peroxide linkage. This part, wherever you see this part, this is called peroxide linkage. Oh, and here oxygen does not have -2 oxidation state. In peroxides, oxygen has -1 oxidation state. Okay. Now, vaguely, broadly, how you can understand it, how many electrons it is getting or it is donating. Oxidation state is always on the basis of transfer of electron. How many electrons it can give to hydrogen? One only. Okay, only one. So it means hydrogen is electropositive, can share one electron +1. Here hydrogen can share one electron +1. +1, to neutralize this, it should have the same electrons gained. So if hydrogen here gives one electron, the same electron this oxygen will get. It cannot get more than or less than. The charge has to be neutral. So if one element gives 2 electrons, the other species have to gain those 2 electrons. If one element gives 2 electrons, the other one will gain 2 electrons. If 3 electrons, the 3 electrons. Okay, so charges have to be balanced. So in this case, because hydrogen can give only 1 electron maximum, this oxygen can have oxidation state -1 only. So this part is balanced and this part is balanced. Both are balanced. So it is due to transfer of electrons. Now, in between oxygen and oxygen, there is no transfer of electron. This is sharing. And oxidation state, oxidation number is a phenomenon of transfer of electron, not sharing of electron. Okay. So whenever we have two similar numbers, similar elements, okay, and these are balanced on both the sides equally, symmetrically. So it means in between there is no electron transfer. These are symmetrical on both sides. So in such cases, and we will talk about these type of molecules, so understand the rule. If you have a symmetrical molecule, you will balance the charges in right half and left half if you have symmetry as per vertical line. So whenever you can draw a vertical line for symmetry, left part and right part will balance the charges. So peroxides we talked about, oxygen will have oxidation state -1. So write it down and you need to remember. It means in H2O2, the oxidation state of oxygen is -1, hydrogen is +1. In superoxides, KO2, for example, Now tell me what will be the oxidation state here of potassium and oxygen in KO2. Who will tell me the answer? You can unmute your mic. In KO2, what will be the oxidation state of potassium and oxygen? And you know, Samad, you
So
will
plus
not
one,
answer.
minus one.
Come again.
Sir, I think plus one and minus one.
Mm, no. Any other student?
So plus 2 minus 2.
Come again, Vedant?
So plus 2 minus 2.
No.
So plus 1 and minus 2.
Plus 1 and minus 2. No. Okay. So in this case, how you
Sir,
can
plus three minus one.
Samad, the rule
Yes,
is that
sir.
group 1 elements will always have plus 1 oxidation state. Potassium cannot have other oxidation state. It has to have plus 1.
Okay.
This rule. All alkali metals have oxidation number 1. So if potassium cannot have any other oxidation state, it will have plus 1. And because the molecule KO2 does not have any charge, means sum of all oxidation states must be 0. Understand it what I am saying? If you have KO2 as charge neutral, there is no charge on it. For example, if I say SO4 2 minus, there's charge on this, -2 charge. But KO2 is neutral molecule. It means sum of all oxidation states will be 0. Plus 1 is the oxidation state of potassium. Then you have 2 times, say oxidation state of oxygen is X. Why I am saying 2 times? Because we have 2 oxygen. The sum should be 0. Means X will be equal to -1/2. So oxidation state of oxygen in superoxides is -1/2. In superoxides, the oxidation state of oxygen will be -1/2. Write down all these points. You have to use these. Yes,
Sir?
Yash Arman. Yes.
So why have you written 2x?
We have written 2x because we have separated potassium and oxygen. So we have K and we have O2. Their sum of oxidation state is 0. So K, we know oxidation state is +1. Plus for oxidation state, if it is X, then we have 2 oxygens here. Oxidation state is always one atom, not of O2. Oxidation state is always of one atom.
Okay, sir.
So because we have two atoms, we will say 2x.
Sir,
Yes.
sir, I did not get that, sir. How to identify peroxides and superoxides?
Basically, you can identify by calculating their oxidation states because they will be in the form that the other one will be in normal oxidation state. So this one will always be in normal oxidation state. So if you substitute here +1, you will get here -1/2. Moreover, to identify superoxides will have greater number of oxygens as compared to their normal oxides. So for example, if normal oxides, we say we have the K2O, superoxide here, you know, here ratio is 2:1. Here ratio is 1:2. So if you multiply it by 2, it will be 2:4. Means instead of 1 oxygen, it has 4 oxygens. So superoxide, more oxygens.
Okay, sir. Got it.
So you will compare it with the normal oxide, with normal valencies. So that's why the concept of oxidation state is there, because valencies were able to explain only the normal oxides, not the superoxides, peroxides, etc. Then the next one, oxygen when combines with fluorine. I'm just moving ahead to explain that peroxides -1, superoxides -2. And if you want to remember, these are the examples you already know: H2O2, hydrogen peroxide, NO2O2, sodium peroxide. And these are the superoxide: potassium superoxide and rubidium superoxide. Now the oxygen, when it combines with fluorine it forms two compounds, OF2 and O2F. There are two compounds known of oxygen with fluorine, but the rule is, which we will be talking about later on, that is another rule, that fluorine always has oxidation state -1. No exception. Fluorine always has oxidation state -1. Sorry, it is not +1, -1. -1. In all of its compounds. If it is in standard free state form, that will be 0 again. F2 will have 0 oxidation state. But in compounds, always -1. So if it has -1 oxidation state always, it means it will force oxygen to change its oxidation state. So in OF2, if oxygen has oxidation state X plus 2 times fluorine has oxidation state -1, the sum will be 0 because it is neutral. X will be +2. So oxygen actually is acting as electropositive. And yes, as compared to fluorine, oxygen is electropositive. That's why positive oxidation state. Otherwise, with most of the compounds, you see in peroxides also, in superoxides also, it is negative. Here also negative, here negative. Normal oxides -2. So till now, how many oxidation states we have seen? Standard form 0. Normal form, normal oxides -2. Peroxides -1. Superoxides -0.5. With fluorine, one we have seen +2, the other one we will talk about. O2F2, again fluorine will have -1. So if oxygen has X, it will be 2X plus 2 times -1 equals to 0. 2X equals to 2, X equals to +1. Again positive because it has to uh, behave like electropositive if it is combining with fluorine. Fluorine is most electronegative element. No other element can have negative oxidation state if it combines with fluorine. Fluorine will always have negative oxidation state. So it means +1 in O2F. So this is, I'm talking about oxygen. 0 will be in case of free standard form, -2 normal oxides, -1 peroxides, -0.5 superoxides, -2 OF2, sorry, +2 OF2, +1 O2F. Total 6 oxidative states. Yes, Arjun, I can explain for H2O2 again. In case of superoxides, say H2O2 or say Na2O2. Now I'm explaining for Na2O2. H2O2 I have done. Na2O2 is like, it is peroxide, so it will have this linkage. And then sodiums are attached here. You know, sodium will actually donate the electron. They will get converted to noble gas configuration, okay, neon, after losing one electron. So if I convert them in ionic form, this will be the distribution of charges. Is this clear up to here? Okay.
Yes, sir.
So sodium is balancing its charge with this oxygen, Right side sodium is balancing its charge with this oxygen. So because sodium can donate only one electron, oxygen can get only one electron, not two electrons. So it cannot have, oxygen cannot have oxidation state -2. It cannot get two electrons. It can get only one electron from one sodium. So that's why its oxidation state will be -1, not -2. Is this clear what I'm saying? Because oxidation number concept is just transfer of electrons concept, nothing else. Is this clear what I'm saying, Arjun?
Yes, sir.
Okay. Similarly, the oxygen on the right hand side gets electron from sodium, but sodium can donate only one electron. That's why sodium can have +1 oxidation state, this one -1. After gaining one electron, obviously negative charge, that's why -1 oxidation state. Similar was the case with hydrogen, but hydrogen actually has only one electron, so it cannot donate more than one electron. There is only one electron with hydrogen. Similar case there. Now, oxidation number of hydrogen is +1 normally, except when it is bonded to metals in binary compounds, that is compound with group 1 and group 2 elements. And there is reason again. We know that group 1 and group 2 elements will always have +1 and +2 oxidation state. We have talked about this rule. So you know that. Now, if these compounds, say lithium, sodium, beryllium, magnesium, calcium, etc., if these combine with hydrogen and form hydrides, the hydrides will be LiH, okay, or CaH2 like this, or MgH2. In this case, because lithium will always have +1 oxidation state, it can't have negative, and the sum of the two must be 0. This X has to be negative. So +1 plus X equals to 0, X equals to -1, where X is the oxidation state of hydrogen. Similarly, say in CaH2, calcium is group 2 element, will always have +2 oxidation state, +2 times oxidation state of hydrogen, sum will be 0. X will be -2 divided by 2, that is minus. In these cases, where it is forming binary hydrides. Binary hydrides means there are only two different elements, calcium and hydrogen, lithium and hydrogen. Means we are not talking about lithium aluminum hydride, because lithium aluminum hydride has three elements, not binary. It's not binary. It's tertiary, not this one. In binary hydrides, hydrogen has negative oxidation state -1. Otherwise, in all its compounds, always +1 oxidation state. So tell me how many total oxidation states hydrogen can have? Just respond in the chat window. If you get this question, how many total oxidation states hydrogen can have? What will be the answer? Arman, no. Yash Bedi, no. Arjun, no. Amir, correct. Kavish, correct. Kartike, no. Sabve, yes. Ishwar, yes. It will have three oxidation states, 0, +1, -1. Don't forget 0. And I have already told you that students make that mistake. All elements in their standard free form will have 0 oxidation state. So total 3. Next one. In all its compounds, fluorine has oxidation number -1. This is something I have already told you. No exception. Without any exception. Other compounds of the same group, 17 elements, can have other oxidation states. Okay. Fluorine can actually have, +3, +5, +7 oxidation state as well. Okay. So we will be talking about those elements, those compounds later on, but fluorine only -1. 6. The algebraic sum, and this is something we have done already. The algebraic sum of the oxidation number of all the atoms in a compound must be 0. So this is something we have done in KO2, etc., H2O2 when we explained here. The sum of oxidation states will always be 0 because the molecule is neutral. But suppose if we are talking about ions and not monoatomic ions, multi-atomic ions. So say we are talking about SO4 2 minus, CO3 2 minus. Then the sum of oxidation states will be equal to the charge on them. Okay. So sum of all the oxidation states will be equal to charge on them. So if I say CO3 2 minus, I will say carbon has oxidation state +4. Oxygen is 3 and normal, this is normal oxide, so it will have -2. So 4 minus 6 -2, and yes, it is -2 indeed. So the sum of oxidation states in case of polyatomic ions, CO3 is polyatomic ion. There are more than one atoms in this ion. So that's why polyatomic ion. So sum of oxidation states will be charge. And it is actually same thing for molecules. Molecules do not have the charge. That's why it is 0 in that case. Now, next concept is stock notation, which is very simple way that the oxidation state sometimes in a compound is mentioned in Roman numerals. So sometimes when we write the compounds, we write it like this. Now, tin has oxidation states too. So sometimes oxidation state is written just after the element in Roman numerals. Instead of writing SnCl2, it is written Sn and then its oxidation state Cl2. This is known as stock notation. If you are asked about it, the expression of oxidation state in Roman numerals is known as stock notation. Now the types of redox reactions. A few of these types you have already done in your previous classes. Okay? So for example, combination reaction, dissociation reaction, etc., or decomposition reaction, you know already. But in redox, the concept is specifically related to when oxidation and reduction both are happening. So we are not talking about all the reactions, combination reactions. We will be talking about only those combination reactions which are actually redox reaction, means reduction and oxidation both happening at the same time. So how many types are there? The first one is combination reaction. And there are certain rules also which are different from other combination reactions. Okay? So first of all, combination is when more than one elements or compounds combine and
To
they
form a
form
single product.
single product, right? That is combination. But here the condition is that at least one of the reactants, at least one of the reactants must be in three elemental form. Say H2, Cl2, Fe, for example, Cl2, H2, O3, Mg, Al, like this. At least one, either A or B or both. At least one means both can also be in their three standard elemental form. So it is of this form. Either A and B or both must be in elemental form for such a reaction to be a redox reaction. Otherwise, the reaction will not be redox reaction. Because we already know that. That's why we have written it in definition. Examples: C plus O2, CO2. Now see what Why it is required? Because in CO2, if this one has plus one of plus positive oxidation state, not plus one, positive, this will have negative oxidation state, only then the sum will be zero. Both can't have positive. Okay. So if both can't have positive, one will be positive, other one will be negative. So for this to be a redox reaction, you should have one element at least here which has zero oxidation state. That's why in elemental form, so that if the oxidation number is increased, it is oxidation. If oxidation number is decreased, it is reduction. Do you remember the sixth rule of oxidation? We talked about the definition of oxidation. The sixth point was increase in the oxidation number is oxidation. So here in this case, carbon to CO2, it is oxidation because 0 to plus 4 oxidation number increased. But oxygen 0 to this oxygen, it is reduction because from 0 to minus 2, it is reduction of minus 2. This part is reduction. This part is oxidation. Both oxidation and reduction happening. That's why we will say it is a redox reaction.
Sir,
Yes.
sir, why did we take carbon as +4?
Carbon normal valency is +4 and carbon's oxidation, normal oxidation state is +4. So just simple point that if we are not we have talked about the rules, okay, of oxidation state. And if you don't have any such rule applied here, the valency will be equal to the oxidation state.
Yes,
So
sir.
carbon normal valency is +4, oxidation state will be +4.
Okay, sir.
Okay. Otherwise, you need to remember those rules. Those will define the oxidation state.
Yes, sir.
Now, similarly here, from 0 to +2 is oxidation, and from 0 to -3 is reduction. In this case, you see there is only one in free standard form. Okay, here. But here also you will see that one will be oxidation, one will be reduction. So if you see here, carbon. Now remember the rule. Hydrogen will always have +1 oxidation state except when it forms binary hydride with group 1 and 2 elements. Is carbon group 1 or 2 element? No. It means hydrogen here will have +1 oxidation state, and accordingly carbon will have negative oxidation state. So rule applied there. Hydrogen +1 oxidation state except binary halides of group 1 and 2. So yes, carbon is not group 1 and 2. It means hydrogen will have +1 oxidation state. Now the sum of oxidation states will be 0. So if carbon oxidation state is X, hydrogen is 4 times 1. You have 4 hydrogens +1 oxidation state, sum 0. You got X equals to -4. So carbon has -4 oxidation state here. So learn to apply the rule. If you see now, carbon, this carbon to this carbon, -4 to +4 means it is oxidation. Moreover, even if you don't apply this rule, when you move from methane to carbon dioxide, oxygen gets added, which is oxidation. Hydrogen gets removed, which is oxidation. Is that clear what I am saying? From CH4, hydrogen is getting removed. Removal of hydrogen or any electropositive element is oxidation. Memorize all those rules. Addition of oxygen is also oxidation. So even if you don't remember, don't apply the oxidation number method here. However, in few cases, you will have to apply this method. Okay? Addition of oxygen is oxidation. The removal of hydrogen is also oxidation. So it means it is oxidation. And here also you see -4 to +4 increase in oxidation state. Okay. So it got oxidized. Now the reduced part is this. Either this one you can consider, okay? Normally you consider the same compound. So from 0 to -2, decreased reduction. Next one is decomposition reaction. Decomposition reaction is just opposite of combination reaction. Just opposite. Means one compound broken into two compounds or more than two compounds, and one of the products must be in free elemental standard form. So it is just opposite. So you see these two are in free elemental form, the condition satisfied. One compound broken, here one compound broken, here also one compound broken. So in this case also you have one standard free state form, here free state. So conditions met. Now you need to think that in which particular case it is reduction, in which particular case it is oxidation. So increase in oxidation state is oxidation. From -2 to 0, it is increase. So this part is oxidation. From +1, hydrogen here +1 to 0, reduced reduction. Similarly, here sodium +1 to 0, in elemental form it will be 0. Okay, in compound form it will always have +1. That is the rule. So this one is oxidation. And hydrogen from -1 to 0, it is increase. -1 to 0 is increase in oxidation state. It is oxidation. Sorry. It is reduction. It is decrease. It is +1 to 0 is reduction. Next, consider this. Yeah. Potassium in all its compounds will always have +1 oxidation state. So plus potassium will not be considered. Here also it is compound. Here also it is compound. So no change in oxidation state. Okay. But chlorine +5 to -1 reduction. Oxygen -2 0 increase oxidation. So all these examples you should write and memorize. Whenever these questions are asked, you need to write these examples. And if anything is not clear, let me know if there is any problem, if any step you are not getting.
So can you repeat the step again?
Which one?
So the second.
Second one, first you have to understand why the oxidation states are like that. We talked about that sodium will always have oxidation state +1 in its compounds. And we also talked about hydrogen will always have +1 oxidation state in its compound, except when it combines with group 1 and group 2 hydrides. And here it is combining with group 1 hydride. It means in this case, it will have -1. It cannot have +1. Group 1 will have +1. And in elemental form, oxidation state will always be 0 in elemental form. Now you compare the change in oxidation state of sodium. Sodium oxidation state from +1 to 0, it means it decreased. +1 to 0. So decreased, that's why this is reduction. Hydrogen oxidation state -1 to 0. -1 to 0 increased. It is oxidation. Is that clear?
Yes, sir.